Okay, so in today's class, we're going to do past paper questions on the topic sound. The first question here says, a device at the bottom of the sea emits a sound wave of frequency 200 hertz. The speed of the sound in seawater is 1500 meters per second. Calculate the wavelength of the sound in seawater. Now, what is the formula for wavelength? Tell me. Hello?
Yeah.
Tell me the formula for wavelength.
Oh, you're asking me? Oh,
Yeah.
I thought you were talking to the class. V equals
V equals
F lambda.
lambda. But this is not the formula for wavelength. V stands for the speed.
Okay.
So I made a triangle here, if you can see, and I told you the one at the top here, V, in order to find the speed, V equals to F lambda. So the two at the bottom, they get multiplied together. In order to
Oh,
find the lambda, V divided by F. You can see this one line, and then you see the difference. So this is division. V divided by F. So the formula for lambda is, you need to memorize this because you won't get it in the examinations. Lambda equals to V divided by F. Now, what is the speed?
the speed is 1500 meters per second.
It is 1500 meters per second. What is the frequency?
200 hertz.
What is the frequency?
200 hertz.
Now, put this into the calculator. What's the answer?
1 second. It is 7.5.
7.5. 1 second. Okay, so the reason why I wrote M next to the answer is because wavelength is measured in meters.
Okay. Yeah.
Read the next question. The sound wave passes from the seawater into the air. State what happens, if anything, to the frequency of the sound. What will happen to the frequency of the sound when the sound wave is passing from the seawater into the air? What's happening to the sound? Will it decrease? Will it increase? Or will it remain the same?
Sound wave passes from the seawater into the air. It'll increase.
No, the frequency does not change.
Oh.
We've studied this earlier in the topic sound, where I told you the frequency will never change. Only the speed and the wavelength will differ. The frequency will always remain the same. The frequency will always remain the same. It will not change. Now, what will happen to the speed of the sound? Will it increase or will it decrease? It's going from seawater into the air. From seawater into the air.
Mm-hmm. The speed will increase. Speed and wavelength, I think, will increase.
The speed will increase.
Yeah.
No.
It'll decrease.
Yeah.
But that's confusing me. Like, isn't it like less denser
Now see,
air?
seawater is more denser than air. So when
Yeah.
it's denser, the frequency of the sound will not change, but the speed of the sound, it will decrease. Why? Because it's going from a denser medium to a less dense medium. It's going from a denser medium to a less dense medium. If it was going from the air to the seawater, okay, then it would be completely opposite. It would increase, but the frequency would still remain the same.
Okay.
Okay.
Can you explain? Can you explain the why it'll decrease? Like, what's the reason?
Because it's going from the denser medium to a less dense medium. That's the reasoning of this thing.
Okay, so that's the case all the time,
Yeah,
from
so
less
it's
to
like it's going from a denser medium to a less dense medium. Let's take an example of oil. Okay, you're transferring an oil. It's denser than water, yeah? So you're
yes.
transferring an oil into a empty water bottle. Okay? And then you're
Hmm.
transferring water into an empty water bottle. Which will fill up faster, oil or the water?
The water.
The water, yeah? And what about the
Yeah.
oil?
It'll be slower.
Yeah, why is it slower? Because it's going from a more dense medium to a less dense medium.
Ah.
So you will see the
Okay.
speed is going slowly, slowly, slowly.
Yeah.
Yeah? All right.
Yeah, yeah. Okay.
Question number 2. Figure 6.1 represents the waveform of a sound wave. The wave is traveling at constant speed. On figure 6.1, label with the letter X the marked distance corresponding to the amplitude of the wave. Label with letter Y the marked distance corresponding to the wavelength of the wave. Now tell me, what's the wavelength and what's the amplitude?
What's the wavelength and what's the amplitude? Label
This
letter
will
X.
be your amplitude. So you mark it as X. And what's the
Yes.
wavelength?
The the one in like in between the two.
This one?
Yeah.
No. Wavelength is from one crust to the another
Oh,
crust.
the crest to the crest. Okay. I forgot.
Tell me, which one?
Um, that like on the right
This one?
up. Yeah, yeah.
But this is not a complete wave. I believe it
Yeah.
would be from here till here. Is this a complete wave? From this point,
Um,
if you see from this point till this
yeah.
point, I think that's the complete wave. So I think you can say this is the wavelength.
What? I thought the wavelength was mainly from
Yeah,
like
if you see from one crust to one crust, it's fine. But here, if you see from this point, from this crust, the crust here, the wave is not being completed. It's a half wave. The
oh,
wavelength is
oh,
half.
okay, so it's like
If this would be
literally the
this
diagram.
would be a complete wave, then I would say, yeah, this is a wavelength. But like let's measure the distance from here, from here till here. If you measure it, it's a complete wave. Yes.
Okay, yeah.
State what happens to the amplitude of the wave if the loudness of the sound is increased at constant pitch. I taught you about the loudness and the pitch. Yes.
Mm-hmm.
So tell me, what will happen to the amplitude and the wavelength? The
Loudness,
loudness of the sound. If the loudness of the sound is being
loudness.
increased, what will happen to the amplitude? Your amplitude will become like this, or will it become like this?
No, it'll become like the first one.
So that means the amplitude will increase. Yes.
Yes.
What about the wavelength?
Wavelength will decrease. It'll
Will
get
stay the
shorter.
same. It will stay the same.
How come?
See, I just showed you an example. Let's say the sound is loud. So the wavelengths will be the same. But
Okay.
you see the wavelengths here, they will be the same.
Yes.
Okay. The pitch of the sound is increased at constant loudness. The completely opposite thing which we said here will happen. The amplitude will remain the same, but the wavelength will decrease.
All right, I understand.
Okay? Clear?
Yes.
Now, do this question. This is a difficult question. It's for 3 marks.
Okay.
The ship uses pulse of sound to measure the depth. To measure the depth. To measure the
Depth.
depth of the sea beneath the ship. A sound pulse is transmitted into the sea, and the echo from the seabed is received after 54 meters per second. The speed of sound in seawater is 1500 meters per second. Calculate the depth of the sea beneath the ship. How are you going to do?
Whoa. Yeah. I couldn't do this question when I was doing the worksheet.
Okay, what are the quantities given here?
Quantities, the speed of the sound.
So what do you mean by depth?
Uh, like depth. How do I explain that? I mean,
Okay,
I know what
can
depth
you
of the sea
say
means.
can you say depth and the density will be del and the distance will be the same thing?
You lagged. I couldn't hear you.
Can you
What's the same
say
thing?
the depth and the distance will be the same thing?
Yeah.
Yeah. So
Yeah, I'd say that. Yeah.
we can use a formula V equals to D over T. Okay, speed equals to distance over time, but here I'm using V because of velocity. Okay,
Okay. Okay. Okay.
now what do we need to find? The distance. Yes,
Yes.
we need to find out the distance. Distance is equal to, wait, distance is equals to velocity times time. But there will be something different. What will be different?
Maybe something different.
Yeah, read the question. We spoke about the depth, but there's one more thing which I underlined.
Echo.
Yeah. What do you mean by echo? Echo means when a sound hits an object or an obstacle, it bounces back. Yeah.
Yeah.
So when you're calculating the echo, you're hearing the sound twice. Yes. Echo means you're hearing the sound twice.
Twice.
So this value, which is your speed, you divide it by 2. Why do you divide it by 2? Because it's an echo. Because it's an because it's an
Echo.
echo. So echo means you're hearing the sound twice. So let's say you have 2D. 2D means two distance. Because once it's going, let's say this is the obstacle. Once the sound will go and then you'll hear it back. So 1 and 2.
Yes.
Yes?
Yeah. Yes. Yes.
Now is it clear?
Yeah. That's clear. That's clear.
Okay. So you put 2D. Why? Because you're hearing the sound twice. Now when you solve it, let's say 2D equals to what's the speed? Convert,
108.
okay, convert 54 meters per second
Oh, we have to divide
into
it, right?
meters. So when you convert
If
54 meters per second into meters, it will become 0.054. Okay?
okay.
It becomes 0.
0.54.
You divide it by 1,000.
Yeah.
54 divided by 1,000, which is equals to 0.054. Now it's in meters. Okay? Now let's solve.
Mm-hmm.
What's the speed?
1500.
That's the speed of sound. I'm asking about the sound pulse, sorry.
Asking about the sound pulse. 54 meters per second, right? But we converted it to 0.054
Okay,
meters.
fine. Yeah. So 1500 times 0.054. Yeah.
Yes.
Now what are you gonna do? Now basic math, just divide this by 2. And
Okay.
now solve it. D equals to 1500 times 0.054 divided by 2. What's the answer?
Let me check. Calculator. Yeah, what's that? Okay, 0.054. Oh my god, I keep writing wrong. Times 0.054 divided by 2. 40.5.
40.5. So if you round it off, you could say it as 41. So 41 meters is your final answer. Did you understand?
Yes.
Here, V is basically the speed of sound.
Yeah.
V is basically the speed of
Sound.
clear.
Clear.
A sound wave in air consists of alternate compressions and rarefactions along its path. Explain how a compression differs from rarefaction. It's for 1 mark. It's really easy. I thought you could say that compression is a region of high pressure. Okay,
Yes.
that's it. Compression